Let's talk about classifying matter based on what is in the sample that we're looking at, the composition of the sample. So when we're looking at a sample, we have two very broad categories that we can put it into. We can have a pure substance, which is essentially saying we have only one thing in the sample, or we can have a mixture. So a mixture would be more than one thing in our sample. Now, the reason why I specifically say we have one thing or more than one thing is because we can actually subcategorize this a little bit as well, because a pure substance is not limited to just having a single atom. We could also have a single compound, and a compound is made up of multiple different elements. So if we look at some of the possibilities here, if we have a pure substance and that thing that we have is just one element off of the periodic table, which I know we haven't talked about the periodic table yet, but I'm sure you've seen one before at some point in your life. If we just have one thing from the periodic table, that would be a pure substance that is an element. And so we could categorize it based on that. We just have one thing, and it's only one thing off of the periodic table. But we could also have a pure substance that is a compound. So if we had pure water, for example, so we had a sample where the only thing in the sample was water, so in that case it is a pure substance because we only have one thing, we only have water. But water is made up of multiple elements. Water is H2O. So we have more than one element present, but all of it is arranged the same way. It's all in the form of water. So if we had, water and H2O2, which is a hydrogen peroxide, if you're not familiar with that molecule, we still only have oxygen and hydrogen, but because we now have two different compounds, we could no longer call that a pure substance. That would be a mixture at that point. And by the way, if you have hydrogen peroxide in one of your drawers in your house, it is actually a mixture of these two things. It's a mixture of water and H2O2, hydrogen peroxide. And it is slowly but surely turning into more and more water. Hydrogen peroxide is actually not terribly stable. It breaks down over time into water and oxygen gas. If we have a mixture, on the other hand, that mixture can either be homogeneous or the mixture can be heterogeneous. So this is a heterogeneous mixture. And it's heterogeneous because it's not the same throughout. It's not fully mixed, essentially. So there's a region here where there's more of this yellow-green stuff here. It looks like there's maybe some tomatoes or peppers there in the middle, and then some kind of cream maybe on the bottom, or something like that. There's different regions of the mixture. It's not the same throughout. That is a heterogeneous mixture. A homogeneous mixture would be something like the atmosphere, where everything is completely mixed. If you take a look at one area of the sample, it will have a certain composition. There'll be a certain number of different kinds of molecules or atom present. And if you look at a different area, you'll see the exact same thing. That is a homogeneous mixture. So heterogeneous mixtures, it varies, the composition varies throughout the sample. Homogeneous mixtures, it is completely the same everywhere in the sample. The ocean, theoretically, is the same thing here. So you can see in this nice clean water here, yes, there are multiple things present. You have water molecules, you have salt molecules, but they're all evenly mixed together. And so that would be a homogeneous mixture. So here's a few other examples here and a nice little flow chart to help you visualize what we're talking about here. So everything could be classified as matter, but then we can take that and separate it into either pure substances or mixtures, and then each of those have their own subcategory that we could put things into. So copper, for example, if you just have a piece of copper, copper is an element from the periodic table, and so that would be a pure substance that is an element. If you have a sugar cube, that would still be a pure substance because the only thing that's present is the sugar molecule. But there's multiple different elements in the sugar molecule, and so that would be a pure substance that is a compound. If you had some tea with sugar, or even tea without sugar, would still be a homogeneous mixture. So you have the water molecules, you have the tea molecules, you have the sugar molecules, but they're all evenly mixed together. If you take one sip of tea, it's going to be the same as the next sip of tea. So that is a homogeneous mixture. A heterogeneous mixture is where you have different regions of the mixture. You have different composition from one area to another. So a mixture of water and oil would be a heterogeneous mixture. So let's do an example here. At least one of these we've actually already talked about. But I want you to go ahead and look at these 5 examples. And I have images to go along with each of these to help you decide how to categorize these. So go ahead and pause the video and think about how you would categorize these 5 things into these 4 categories here. So pause the video now and give that a try. Alright, so the first one here, coffee. If we're going with this cup of coffee, which I told you should, again, I wanted you to use these images to help you figure out what they are. This would be a homogeneous mixture, because it's fairly obvious this is just black coffee. This isn't one of those super fancy drinks you get at Starbucks somewhere. I'm not a coffee drinker, by the way, so I don't even know what to call them. But I know that there are certain coffee drinks where it is actually heterogeneous, where you can see there are differences in the drink because it's not the same throughout. You can actually see different colors in different areas just depending on how well it's mixed together. But this is just black coffee. There's, nobody drew a picture in it like you see sometimes. And so that would be a homogeneous mixture because you have water molecules there, you have coffee bean molecules. If they happen to put a little bit of sugar or something in it, you would have some sugar molecules in there. That would be a homogeneous mixture. Same thing with the seawater. That would be a homogeneous mixture. Although I would like to point out that where you take the sample does actually make a difference here. So this seawater, it looks pretty clean to me. But if you were to go out, a few feet off of the beach in some place in the Gulf of Mexico somewhere where they have not done a good job of cleaning, you would probably not get a homogeneous mixture. It would probably be a big mess. You might get some seaweed and a dead fish and maybe a beer can. You would get all kinds of different things in your sample. So where you take the sample does matter. But in this particular image, that looks like a pretty clean, pretty homogeneous sample of seawater. Gold would be an element. Gold is on the periodic table. If we're going to assume that this block of gold is pure gold, then it would just be a pure substance that is an element. The marble is the one that really gets students. This is the one they make mistakes on the most often. This is a heterogeneous mixture. They try to say that marble is a compound, which is not technically true. There are compounds in the marble. There are multiple compounds, in the marble, but just by looking at this sample, you can see there are areas that are black, there are areas that are white, and there are gray areas in between. It's a dead giveaway that you have different molecules if they have different colors. If you have two of the exact same molecule, they're not going to have different colors. They will look exactly the same. So because we have different colors, this is obviously not, well, I shouldn't say obviously, because it's not obvious, but because you have different colors, this is definitely not homogeneous. If it was homogeneous, it would probably just be a big gray slab, because the black and the white areas would mix together. So because there are differences, so if I take a look at the molecules here, that's going to be different than the molecules here. And just the color shows us that. This is a heterogeneous mixture. And then the last one here, salt, that is a compound. Salt, table salt, is sodium chloride, which has more than one thing present in it. It has sodium and chlorine, both of which are elements. So the sodium chloride, if that is the only thing present, which we are assuming it is, since I just told you it was just salt, that would be a pure substance that is a compound. All right, we'll call it there for this video. In the next one, we'll talk about physical versus chemical properties.